Hello, everyone. Thanks so much for joining us today. This is Cammie Nixon, the product marketer here at DataStax, and I will be moderating today's presentation, Big Data Security with DataStax and Gazzang. First, a few bits of housekeeping. All listeners are on mute, but you can ask questions using the Q&A field on your WebEx view. For the first half hour, we'll hear from big data security experts, and the second half hour will be dedicated to a roundtable discussion. We've already queued up questions from the registration process, and you can also add questions in the Q&A field. We are recording today's broadcast, and we'll send it to you during the next few days, along with an original white paper. So please watch your inbox for those links. And now I'd like to introduce Greg Greenstreet, Adjunct Professor at CU Boulder and Vice President of Engineering at Gnip, which serves social data to 95% of the Fortune 500. Greg has 25 years of software engineering experience, which has included serving as Chief Technology Officer of Collective Intellect, a social media analytics firm recently purchased by Oracle. Just a quick background for the audience. I work now at a company, Gnip, that I followed, actually a social media company I started called Collective Intellect, which was recently purchased by Oracle. And so I've been in the social media world for 8 years now, I guess, on a large scale. And Gnip is really the utility company for data for many of the large social media publishers in the world that provides data to companies like my former company. And so we see the full Twitter fire hose, for example, and Tumblr and Discuss and WordPress and many, many other large publishers come through our pipes each day. So a lot of my experience in big data has been based around social media. But I think, one of the interesting things that at least I was able to do in my last company is instead of processing only a sample of the data, we're now able to actually process all of the data in some cases. And I think, when I look back, big data seems like just another hype. The Silicon Valley hype cycle has begun on the word big data or the term big data. But I think there's really something larger going on in our world, which is for the first time, we can actually take all of this data and process all of it and not just samples of the data and try to come up with some causality out of that data. We can actually look at all the data. And so there's interesting examples that have already happened. Google, of course, is a very large company that has kind of pioneered some of these technologies with their big table implementation. And, they've been able to actually take in all of the search data and run mathematical models so they can actually predict the spread of viruses and flu faster than the medical authorities can. And so it's just an example of the correlation that you can derive from looking at all the data and maybe not even understanding why those 45 search terms or whatever they came up with were the mathematical model that accurately predicted the spread of H1N1 as it came across the country. But you actually have a model that works. And so I think there's a larger movement in our understanding of data that's going on behind the scenes, which is you don't actually have to come up with the why. You can actually use data. You can embrace some messiness of the data in the real world. Not all the data is going to be exactly, clean, but it's down to percentages now. And so you can get some relative confidence about what you think is going on by running these models. And of course, the frameworks that have emerged from a lot of these large internet companies like Facebook, like Google, like Amazon have started to enable that and moving away from the single kind of machine database technologies of the 80s and 90s. The databases still have their place in the world, of course, but much of the data that we have now is not transactional. It's factual in nature, and we don't want to run these relational queries. We have other algorithms we'd like to run on them, and so frameworks like Cassandra and Hadoop and and many of the other specific databases are starting to enable that in a clustered way too, which is the other large change. I think we don't think of database servers anymore. We think of clusters of servers, so we can use commodity hardware and to accomplish our replication and our spreading out of the data and actually bringing the code to the data. So I imagine most of the people on this webinar, this is academic to them, but I think it's the real change that's going on right now that I see, since I've been in computer science for 25 years. And I watched the object databases come in the 90s and, try to be a contender to the relational database world and then slowly fade away. And I think that was mainly because at that time, it was more of a programming, nicety to be able to store objects and get those back and not have to translate that into a relational model. And then the mapping frameworks came along, like Hibernate and IGOTUS, and then all of a sudden the problem relatively went away. But I think there's a fundamental difference now with frameworks like Cassandra, where it isn't just a programming problem, it's an actual storage problem, it's an actual ability to process the data in a clustered way. So I think there's just a large, at a very large macro level, there's just a big change going on in the world. And so you see this in, all kinds of industries, right? Not just social media where I live, but, one of the things I thought was especially interesting is the time it took to sequence the first pairs of DNA. There was the Human Genome Project started, I think, in 2003, and it took them nearly a decade of work to sequence the 3 billion pairs, right? And now I think a facility can do that in a single day. So I think we're starting to see that change in our world. I think we're just kind of at the start of this, and it offers some interesting questions. I have a bullet here that talks about what are the societal and ethical questions that are going to be there, and I think it's going to be around not understanding why necessarily things happen. If you have cancer and you take a certain drug and drink orange juice, the model shows that you have this degree of success, and we may not understand why that is, but that's what the data shows. So I think there's some interesting things there. To get more concrete, my company uses Cassandra in lots of ways for lots of different products. That just, we don't have a need for relational databases, or the relational databases just couldn't keep up with our write loads. Storing the entire Twitter fire hose on an ongoing basis is just not something a cluster of MySQL servers is really going to excel at. I think the questions around security are much the same that existed in the relational world for a long time. For my company, even though we deal in public data, we still have the same kinds of questions. And it may not be the data itself that we need to encrypt, but certainly our customers upload filters for that data. And so, if you're a hedge fund, you have some actual need for other people not to get to that data. And so all the same kinds of disciplines apply here. I have on the slide here, internal authentication. Does the database itself support this? Can you put ACLs on certain pieces of the data? Is the data, when it's in flight, is that encrypted? And then, can you start to use external security packages that are outside of the database itself? Can that be integrated? And then, securing the data at rest. Can I encrypt that data in a transparent way, with minimum performance decrease? And, then with all the encryption algorithms, the obvious question is, well, where do the keys live for that encryption? How do my servers manage and access those keys? And then, data auditing of what actually transpired. And so these are things I think we take for granted in the relational database world that have largely been worked out, but are, as people, move from relational databases into NoSQL stores like Cassandra, the same questions start to come up. And I know it's important for Gnip in that, even though we deal only in public data, we still have all these clients who are very interested in protecting the rules that they upload to us for filtering. They have ISO standards that they want us to adhere to. So I think it's actually applicable to any company, even if you don't have very sensitive data, if you don't have HIPAA data, for example, or DoD data in your database. I think it's still the security questions never really go away. So I guess with that, I would go ahead and introduce Robin to start the security So Robin, got his start as a database DBA and in the guts of things, and worked his way up into product development, and was there for MySQL, and I think there was a $1 billion sale there, so that couldn't have been too bad for him. So I'll introduce him. He's a husband of one, which I find entertaining, father of two, as I am, and forced against his will to have a horse, which I also, when I was young, took care of a horse, so I can understand the against his will part of that, of the 5 a.m. cleanings of the stall. So Robin, if you want to take it away.
All right, great. Thanks very much, Greg. So Greg has given us a good introduction to big data. And one of the things that literally all the analyst firms agree on, and they don't agree on many things, but they do agree that you need an alternative technology to process it. And legacy, traditional relational databases, as Greg described, just really don't hold up under the load. And in fact, Fortune, just a day or two ago, came out with an article along with DICE describing what skills people are looking for in terms of handling big data. And NoSQL was right at the top, not surprising. So what we do here at DataStax is we are an open source NoSQL solution provider. And all of our business is built around Apache Cassandra. Apache Cassandra is a massively scalable NoSQL database. And this database is capable of linear scale performance, continuous availability, has a very flexible and fluid data model, much different than what you'll find in the relational world, and it allows for very easy data distribution across multiple data centers, across multiple cloud geography, availability zones and geographies and what have you. And I want to go back to the linear scale performance for just a moment. We mean this very literally, so that if you are doing, for example, 1 million transactions a minute with 2 nodes, you will do 2 million with 4, and you will do 4 million with 8. And if we can go to the next slide, please. We tend to lead the performance category when it comes to NoSQL crunching through big data. And the benchmarks that we provide are not our own. They come from academia, they come from our customers, and they come from independent software technologists. And in every case, what you will find is that linear scale performance that I talked about. I can't promise you that we will be the fastest in every use case. I don't think any database can. But what we can promise you is that, again, if you need to future-proof your application, then you will be able to do that with Cassandra and its linear scale performance capabilities. Next slide, please. So who are we here at DataStax? Well, again, open source, NoSQL solution provider, founded in April 2010, and we drive Apache Cassandra. We have the Apache chairman is one of our founders and employ most of the committers here. Currently, we have about 250 customers, over 100 employees. We are headquartered in the San Mateo, San Francisco area. Next slide, please. You might be surprised to see the number of customers and the different industries that we actually serve. One of the things that has struck me about NoSQL, I have never seen a faster adoption of any database technology since I've been in databases, and that's been over 20 plus years. So whether it's a typical relational, whether it's object, whether it's OLAP, I've never seen a technology introduced and put in the critical path faster by major corporations than I have NoSQL. And we're seeing that very much here at DataStax. And again, this is a smattering of some of the customers and industries that we serve. Next slide, please. So what we do with Apache Cassandra is we take Cassandra and we perform a certification process to ensure that it's ready and battle tested for production environments. And we provide a solution called DataStax Enterprise, which is really our NoSQL, again, solution for the enterprise. And what that solution delivers is the online real-time capabilities of Apache Cassandra combined with the analytic processing abilities, batch analytics of Hadoop, and the enterprise search capabilities of Apache Solr, which is the most popular enterprise search platform really in use today. And we're able to provide, again, a single database cluster that allows you to perform all your online real-time work, batch analytics, and search with workload isolation so that none of those workloads will compete against any of the others for resources, or for typical functionality. All of it's separate inside of our database cluster. And so when you subscribe to DataStax Enterprise, you will get that server, you will get our visual enterprise ops center management tool, and you will get expert around-the-clock 24/7 support. That is what we provide here at DataStax for the enterprise. Next slide, please. An example of one of our customers, Healthcare Anytime. These guys found their application. They do online healthcare portals, provide a lot of patient information online, deal with a lot of hospitals, crunching through lots and lots of data, hit the wall with their relational database, couldn't go any further with it, turned to DataStax, and now they have a single solution where they're able to handle all their online applications, process batch analytics with Hadoop, and then do all the types of search functions that you can imagine. I needed to find a podiatrist that speaks German that's 5 miles from my home. That's the kind of thing that these guys do with DataStax Enterprise. Saved a lot of money in the process and are able to handle, again, different types of big data that relational databases just can't process. So for example, these guys have to handle doctor's notes. You can imagine trying to decipher doctor's notes. They get scanned in copies of doctor's notes that they have to analyze and then bill back to Medicare and Medicaid. Again, simply unable to do with a typical traditional relational technology, able to do it with DataStax Enterprise. Next slide, please. So when I got here 2 years ago, I was surprised to find that NoSQL technology in general had either little or no security embedded within it. And again, coming from the relational world, I was just shocked at that. And so because I'm VP of products here, one of the first initiatives I undertook was to remedy that situation. And we have done so with DataStax Enterprise 3 that was introduced earlier this year. We have what I believe to be the most comprehensive security feature set of any NoSQL provider. And what we have done is we have delivered a multifaceted security feature set, delivered some of that to the open source community, and retained some of it for the enterprise world. So for the open source world, those users of Apache Cassandra, we delivered internal authentication that allows you to create IDs and passwords, log in just as you would a relational database, object permission management that allows you to grant and revoke certain privileges on various tables and things along those lines that hold objects that hold data, and then client-to-node encryption so that we protect your data as it's in flight from the client to the actual machine. And everybody gets this. However, the enterprises need more, and that's where DataStax Enterprise comes in. So if we go to the next slide, please. These features are really, again, geared for those situations where you need a little bit more advanced security. So external authentication via Kerberos and LDAP, very popular with financial institutions, government agencies, and things like that. Transparent data encryption. Now, this is a very limited form of encryption that basically is delivered so that if people are interested in having something a little bit more than they might find at the file level encryption layer, need a little bit more granular control, this is what we do. But again, it's a rudimentary form of encryption. The keys are stored on the server. That sometimes violates various security regulations and what have you. And if you need more, that's again where someone like Gazzang comes in. The other feature that we delivered in 3.0 of DataStax Enterprise was data auditing. Who looked at what when, who changed what when, very nice and granular form of data auditing that allows you to answer those types of questions. Next slide, please. So if you like what you've heard about DataStax Enterprise and Apache Cassandra, like to kick the tires, make it very, very easy, just go to our website, datastax.com, download DataStax Enterprise. You're able to use it absolutely free of charge in your development environment. You want to put up a 1,000-node cluster on AWS and do your development work against it, feel free. Knock yourself out. We will not charge you a penny. When you do move to production, that is when we do need to discuss production subscription, but I think you'll be very pleased. What you find on the pricing front is we tend to be about 80 to 90% less than the relational databases. Next slide, please. All right, so with that, I would like to turn the reins over to Sam Heywood, who's the Senior Director of Products at Gazzang. Evidently got into programming quite a while back, along with myself, I suppose. Writes code on the weekends, so evidently he's very interested in creating software projects. Does a great job there at Gazzang. You can see a great picture there of his wife and family, and not a guy you want to mess with. Evidently is into jiu-jitsu. So Sam, I'll go ahead and turn things over to you.
Oh, okay. Thank you very much, Robin. The jiu-jitsu is mainly because of the pretty lady standing to my right in that picture. It's the only hope I have to defend myself against her. Anyway, Great webinar so far. I hope everybody's enjoying things. So my name's Sam Heywood, and I lead products here at Gazzang. Really excited to be speaking with everyone today. Real quick about Gazzang. So we've been delivering encryption and key management solutions for a few years now. It's something we get really excited about. We consider it to be an important part of many different kind of application and infrastructure ecosystems. We're really jazzed about everything we see happening in the cloud and big data worlds, because we feel we have a high performance solution that works really well in this space. Steady growth with lots of happy renewing customers. And of course, we're in Austin, so live concerts in the office every Friday as required by city ordinance. It's just something you can't escape down here. And we are indeed a venture-backed firm and happy to be partnered with Austin Ventures and Silver Creek, who you can see there below. All right, so there's two parts to our solution. Endpoint encryption and key management, and we'll kind of walk you through those piece parts and then tie it all together in terms of how it relates to big data solutions and compliance. So Gazzang Z-Encrypt that you see on the screen here, what this delivers is a virtual encrypted file system that appears to the application layer as just a standard file system. What this means is any applications running where Gazzang Z-Encrypt has been deployed can take advantage of the transparent at-rest encryption with absolutely no modifications required at the application layer. The other thing that's important here is because the encryption solution is deployed at the file system level per node within a cluster, as opposed to being a centralized encryption service, it's a massively parallel encryption solution, right? So there are no, massively parallel stuff like Robin was talking about with the purely linear scalability. That's excellent. And what you don't want to do inside of an environment like that is create a choke point bottleneck that takes away all the gains for the parallelization. In addition to the encryption layer, we use process-based ACL controls to determine which processes running on the server can actually access the protected data. So as Robin was mentioning before, you can use identity management tools and things like that to determine who has access to the database processes. And then we provide another layer that says only these processes will be able to access the data. So it's a secondary line of defense against rogue actors. And we are committed to big data solutions. We have package support for Cassandra and other NoSQL platforms that allow users to deploy with confidence that the right data locations are protected and only the needed NoSQL processes are actually given access to the data. We used hardened, tested, approved cryptographic algorithms. We're not cryptographers. We're not trying to reinvent any of that. And of course, we offer the key management solution as well, which we'll talk about on the next slide. So key management is an essential piece of any type of encryption scheme, and Gazzang Z-Trustee delivers this capability. The way I like to think about key management is as follows. My dad's Cadillac was in the driveway every day of my life. It was right there, and I could touch it, but I did not have access to the keys. So that thing was completely inert. Without access to the keys, that car was totally useless to me, and encryption is much the same way. If you can get to the encrypted data somehow, but you don't have the keys, you're not going to really be able to do much with it. For those familiar with HSMs, you can think of Z-Trustee as a virtual HSM like SafeNet or Thales, but with a cloud-friendly form factor. In our case, you don't have to go ram a box into the rack to make this thing go. However, we do interface with other HSMs, and you can use those as root of trust or final policy arbiter or whatever if you have specific FIPS compliance issues. Obviously, the key manager, Z-Trustee, is where our Gazzang Z-Encrypt keys are stored, but you can also use it to protect any sensitive items within your environment, including keys and certificates produced by other applications. For instance, if you're using EC2, then you have a bunch of SSH keys that you're using to get into that environment. If you have apps using OpenSSL, then there are certificates and private keys, and all of that stuff can be protected inside of Z-Trustee. Z-Trustee can be deployed in multiple, well, we have multiple deployment options for ztrustD, and this creates some interesting solutions, specifically relative to concerns about data custodian issues when using the public cloud. As we mentioned, if you control the keys, you control the data, and the key manager does not have to be in the same environment as the data itself. And this is of particular interest to customers in the EU, for example, looking to run Cassandra cluster in the public cloud, but concerned about Patriot Act. Sophisticated policy controls around the key management that include geolocation, access times, rules about single access, etc. But one of the other things we offer is multi-factor access control for the key itself. So as an example, let's say you've got a private key tied to an SSL certificate, and a server has sent in a request, or what appears to be a server has sent in a request for this key. We can actually bring humans with context into the equation to be final arbiters around whether or not that key should be released to that requesting server. So if you've got something highly sensitive, you can set up these human trustees, and when the request comes in, they can actually out of band go verify that indeed it's a legitimate request for the key or the certificate, whatever, authorize it, and then our system will release it back out to the requesting system. One other interesting thing to point out is while these trustees are responsible for controlling access to the key, they really don't know what's in the key itself. They are completely shielded from the data within. Very similar to, say, a safety deposit box in a Swiss bank, right? They take responsibility for managing access to the thing, but they really have no idea what's in it. Our trustee system works in much the same way. So we feel that ztrustD, with the core key management capabilities, support for keys from other systems, and the crowd-friendly form factor, that was easier to say in my head than actually out loud, the cloud-friendly form factor and policy controls, including the direct human multi-factor authentication, create an interesting and unique solution to this kind of classic problem around key management. Okay, so let's talk about the compliance officer. Compliance with various regulatory issues is a whole different story. So using our encryption solution in our ztrustD key management, we're able to move you much further along the road towards being able to be compliant. So the high performance transparent data encryption can be deployed underneath Cassandra without any modifications. We're using strong AES 256 encryption algorithms, and there's minimal performance impact. This is a critical part of working through the compliance because, for HIPAA, PCI, FERPA, et cetera, transparent data encryption down on the disk is essential. And we mean transparent data encryption of everything, not portions of the data. The key manager keeps the keys separate from the data, and this is super critical, right? Most of your compliance regulatory bodies are going to drill in on the key management because if you think about the example with the car was right there, but the keys were in Dad's pocket, so it was essentially useless, right? So key management, as I mentioned before, is critical to the whole thing, and it's part of our offer. Combine that with the policy engine specifying who can get to the keys under what conditions, and the ability to apply the multi-factor authentication, of humans with context as a last line of defense, wrap that whole thing in the audit trail, and you really are able to get a clear picture of what's going on in a highly controlled environment. And again, the options around where to deploy the key manager help with issues around data custodian issues. For particular example, EU customer wanting to run Cassandra in the public cloud, they can move all their data up into some public cloud environment, but then what we'll see is they'll take and locate the key manager inside of their data center. And what that gives them is the ability to protect access to those keys with their own kind of legal and compliance teams as opposed to simply relying on the public cloud provider. Finally, the process-based ACLs provide further separation of duties between sysadmin and data admins, ensuring that only those with access to the database processes can interact with the data. And all of the above, while HIPAA, FERPA, and those things require many different aspects to be compliant, the transparent data, the key management, and the process-based ACLs certainly move you much further down being able to meet that compliance. And then lastly, we're very proud of the impact that Gazzang is having far beyond just our 140 customers. Our customers are using our solutions to protect employee health records, student services records, provide secure benefit portals, protect publicly identifiable, personally identifiable information, and critical business information about partners and customers. So while this isn't necessarily genome sequencing, which is amazing stuff, it's just one more example. The world is changing. The usage patterns that people have, their expectations about their ability to get the data, and the ease with which they can get the data is constantly moving forward, and we're pleased to be a part of this ecosystem, allowing delivery of new innovative services to millions of people worldwide. So finally, next steps. If you'd like to learn more about our solution, please send an email to sales@gazzang.com to schedule a demonstration, or visit our website at www.gazzang.com/DataStax webinar for more information. And I think with that, we'll hand it back to Cami to lead the roundtable.
Yes, thanks a lot, Sam. So also, Greg, Robin, thanks for your presentations there. Very interesting stuff. So this is going to be the interactive portion of the webinar today, where we have questions queued up from you all who are listening. In your registration process, you put some questions into us, and then we're also fielding live questions from the Q&A panel. So first question, what is the best way to implement access control to data while still making it available to the system and a small group of users? So I'm going to throw that out to you first, Sam, and then Robin and Greg, if you want to chime in again, feel free. So what is the best way to implement access control to data while still making it available to the system and a small group of users?
Okay, thank you, Cami. Yeah, glad to kind of go first here. I think one of the most important aspects when thinking about security is to think in layers, right? The notion of a single method that can be used to, provide security and flexibility, I think has been shown over time not to be successful. So if you think of security in layers, where layers include, user-based access control, systems-based access control, and then finally access control down at the process level, what Gazzang contributes to this is our process-based ACLs. And what that means is, like, in the case of Cassandra, you can actually specify explicitly, here are the locations on disk where the data is stored, right? These locations are encrypted, and here are the itemized set of processes that can run on the server that Gazzang should allow to interact with the data. These processes, and only these processes, should be allowed to interact with the data. So if somebody gets on the system but doesn't necessarily have access to, forgive me, Robin, I'm not sure what it is, but we'll just call it Cassandra D, the Cassandra daemon, if you will. If the user doesn't have access to the Cassandra daemon, but maybe for some reason they have access to that portion of the file system, we will actually block them right there, because an ls or a dir or a cat or a string or anything like that, none of the processes that user might be able to execute will get past our check, and we won't be able to let them interact with the data.
I guess let me just add a couple things. It really comes down to a number of factors. How sensitive is the data that you're dealing with? And do I really have options that allow me to go up and down the food chain in terms of protecting that data? And so you're going to be dealing with both external and internal types of protection that you want to lay down. And again, this is where NoSQL isn't any different than a relational database. Although most NoSQL databases don't really have good security up to this point, if you're going to deploy it enterprise-wide, you're going to need those options. Sometimes maybe the application will be fine to serve as your only security layer, but oftentimes not. And again, that's why we introduced kind of a multifaceted feature set into DataStax Enterprise 3. So you have a variety of different ways of externally authorizing people to ensure that you're not being hacked, you're not having people try to obtain unauthorized access to your servers and to your database as a whole. And then a granular form of object permission management to protect the various objects that exist in your database, and also be able to track who is doing what, who's changed what, who's looked at what, all of those type of things with auditing if you need to. Sometimes, again, use cases, you won't need a number of those types of things. But in other cases, certain either external or internal regulations will mandate that you do. And so the important thing is you have those options available if necessary. And again, that's the good thing about DataStax 3 is that we provide those things to you.
Okay, you guys ready? If I don't hear anything in a minute, I'll move on to the next question. Okay, so I think, Sam, we might have you start with this one as well. What protections are in place to protect the security keys from corruption? And if corruption occurs, how would you recover your data?
Okay, that's a great question, and I think before I answer, I'm going to kind of define corruption. I'm reading corruption as something different than the keys were simply lost or exposed, right? That's a different situation. So, you know, with that definition in place, I think the question is, if we're using an encryption service, in particular, say Gazzang's and ztrustD, how can we have confidence that the keys will survive and won't get lost? And if they do, how can you recover the data? So ztrustD supports high availability configuration such that there's not any one failure point for the data to be lost. So that's standard there. Just anytime you have data that you want to be, you know, certain survives, they're just standard kind of techniques for taking care of that, and we use all of those. If for some reason the data is completely lost, I have no idea. Like, let's say the data center where the key manager is located, you know, burns down or what have you. You do have the option of configuring passphrases using RSA keys or 15-character passphrases or whatever that, in a pinch, can be used to recover the data down at the encryption endpoint. So you always have that fallback mechanism.
Okay. And if I don't hear anyone chiming in, I'm going to move on to the next one. Okay, so this next question is actually a combination of two. They're very related, and I'm going to kick this one to you, Robin, to start with. So 2 questions in one. In the absence of government or industry regulations, how do I determine which level of security I need? And then the related question is, I don't have HIPAA, PCI, or another compliance requirement for my data. Do I still need to secure it?
Well, let me take the last one first. Absolutely. If you want to get fired, there's a couple things you can do as a database professional. Lose the data and or don't do your backup recovery properly. There's no better way to get fired in your job than to do that. Almost outside of perhaps departmental data that contains very generalized information and or information that really can't be understood or utilized by external parties, almost all databases need to be secured in some form or fashion, externally and internally, to prevent unauthorized access. I mean, I, again, was a database administrator for probably 15 years, and I can't think of a single database I ever oversaw that didn't require some form of protection. So again, absolutely, you need to ensure that you have base security protection in place, both externally and internally, to ensure that, again, you're not having any unauthorized access come into your systems there. And in terms of not having really any standards to go by, it depends on how you want to run this. If you're in a particular larger corporation, oftentimes you will find some form of a security officer or security database professional that will be hired, whose sole purpose in life will be to oversee the governance of security across various database servers and what have you. And they will be charged with creating a set of internal specifications and guidelines that need to be followed. If you don't have that, then I would suggest just going out to a number of the different security IT analyst firms that are available on the web. These guys almost always publish some sort of general set of guidelines that are a good jumpstart to get you headed in the right direction in terms of the what's, how's, and why's of securing your systems, and that would be my first stop, again, if I didn't really have anything else to work with.
Okay, does anyone want to add anything to Robin's response? If not, we'll move on.
Well, yeah, this is Sam. So one simple kind of test that I use for these things is imagine right now that the data was compromised and stolen. Are you suddenly concerned about what's in there? If so, considering some type of security or encryption solution is probably a good idea.
What kind of performance impact can I expect from DataStax and Gazzang security? And Greg, I'm coming back to you with this other larger question, so I hope you can figure out the feedback thing. But in the meantime, Sam and Robin, what kind of performance impact can I expect from DataStax and Gazzang security?
Well, let me start. It's going to depend on the security feature that you're using. So something such as just utilizing external authentication or internal authentication, minimal to none. Same thing with object permission management. But when you're looking at things such as encryption and or data auditing, it's really going to depend on a number of factors. What type of data types am I encrypting? How much data is there that needs to be encrypted? How much data and or traffic am I auditing in terms of, am I auditing everything? Am I only auditing reads? So I'm not trying to dodge the question, but you do need to understand that those factors play a huge role in terms of how much degradation you will receive from a performance standpoint when you implement various security features. To give you kind of a general rule of thumb, almost all databases, relational or otherwise, will have some sort of overhead that accompanies encryption when it's implemented inside the database. Ours can range anywhere from maybe like 5% upwards to 10%, depending on, again, how much data and how heavy duty is the encryption necessary to go after certain data types.
Yeah, and I just want to support what Robin was saying there. You know, security, as we've talked about before, comes in many different layers, and depending upon which layers you have deployed and how you have those configured, you will get different answers. In the case of Gazzang, we plug in right at the file system level. It's designed to be high performance, but there is overhead. You're able to configure our encryption in a couple of different modes. One mode is you can select to protect a particular directory or file, right? That is slightly more overhead. The second mode is you can protect an entire volume. And our volume or block level encryption, when used in conjunction with, you know, Intel chips that have the AES-NI cryptographic coprocessors, are screaming fast. We're working on getting published benchmarks out there, so I don't want to start quoting any numbers now, but easily single-digit performance. The interesting question, though, when talking through performance impact of security, it's a very real thing and something to be considered, but the flip side of that is for the performance trade-off, is it acceptable for the data to be, you know, unsecure or not secured? And the answer is typically no, we have to secure the data. We're just trying to understand what the impact will be.
So let's get it over to Robin or Sam. What do you guys predict in the next couple years, even up to 5 years?
Well, I'll jump on it. Regulation's a funny thing. It's impossible to tell what we may learn, you know, as a you know, kind of national community, if you will, over the next few years that drives changes in how we think about data security. Obviously, you know, cyber threats are very real, and there's constant focus on that. I think, if I'm not, well, I don't want to say something I'm not completely sure of, but I believe there's just a general concern around that. So there's that side of it. You know, regulation is hard to predict. But I would say, I believe more and more we will begin to see an open discussion about the balance between, you know, our phones, if you will, spitting out an incredible exhaust of data about ourselves, about us and our lives, and how that data is leveraged. So, you know, there's a classic balance between the use of that data for our benefit versus the use of that data for exploitation. And I think as we begin accessing more and more services, more and more through mobile channels, and people see continuing improvement in analysis capabilities, like the genomic sequencing thing is absolutely fascinating. I believe those are the types of things around consumer protection that will start pushing the various boundaries of how we secure things now, but it's very difficult for me to predict. So there you go, a bunch of words and a non-answer. I hope that was satisfying.
Perfect. Robin, did you want to add anything?
Well, the interesting thing is the security feature sets that you're seeing today are the ones that were needed, 20 plus years ago. So in some respects, things stay the same, but in other respects, they change. And I think what you're going to see is a push down for greater security coverage and more granular security coverage. So, for example, who doesn't want certain things they do on their mobile phone to be encrypted and to be protected? We didn't have to deal with that, a number of years ago, but today we do. What might we be looking at? Perhaps I need to secure certain portions of a video and be able to ensure that only certain people can view a certain segment of a particular video. Different data type, different way of securing that data, different type of push down, something that could be coming down the pike. So I think those two things are what you're going to be looking at.
Okay, thanks. Yeah, very, very interesting to think about that. That kind of leads us into our next question, sort of. So how do you deploy the solutions? Could you guys make a comment on, bringing it in-house? What do people need to be thinking about? How do you deploy these?
Well, just from a general perspective, from a NoSQL perspective, the primary consideration needs to be given to the data model differences between the legacy relational databases and NoSQL databases. Get that right, and you will be successful. Get that wrong, and you will not be pleased with your end results. We have seen that over and over again, and it doesn't matter whether it's Apache Cassandra or any other NoSQL database out there. Time and again, the advice that our customers give is to spend the time to understand the data model differences and model your data differently than you do in the relational world. That's a key thing that you need to understand. In terms of moving data from existing systems to us, there's a plethora of different options available, flat file loaders, various utilities like Scoop that can move data, ETL tools that fully support Cassandra and streaming data across from relational databases that are free of charge and don't require a big cache outlay to utilize. Those can certainly be deployed very, very easily. And so those are usually the two top questions I get and that people really wrestle with. Data model differences moving from the relational world, and then how do I get my data over to a system like Apache Cassandra? With the latter not being hard at all, you do definitely need to spend time up front with the former.
Okay,
yeah,
Sam, go ahead.
Sure. So with the Gazzang solution, there's the deployment of the endpoint encryption, and then there's the key management. And those are two different considerations. So in terms of deploying the key management, we invest a lot in making sure that, we envision Gazzang Z-Encrypt being used in elastic, bursty cloud environments, right? So we invest a lot to make sure that we support, kind of modern DevOps tools like Chef and Puppet to ensure that these things can be provisioned and torn down without requiring any type of human intervention. So in terms of deploying the endpoint solution, the best way to think of it inside of a big data environment is, we've invested in the tool sets to ensure that these things can be provisioned automatically without requiring human intervention, especially when you're talking about tons and tons of nodes. From the key management perspective, it all comes down to sensitivity around data custodian issues, right? We have a SaaS version of our key manager that's multi-tenant that people can use if that works for them, based upon their use case. Other customers prefer to run the key manager themselves, and sometimes they will deploy that in the cloud. Sometimes they'll deploy that in their own private data center. And then we have other customers, kind of as we've mentioned, who want to make use of, the amazing public cloud services that are available today, but are very concerned about the public cloud providers being compelled to turn over their data. And therefore, what they want to do is place that key management somewhere under their jurisdiction, if you will, and under their control. So they might say, we're comfortable running everything up in, select your cloud provider, but the key manager is under somebody's desk at our general counsel's office in Finland, and there it shall stay.
Okay, thanks. Here's a follow-on question to something you guys were talking about a couple of minutes ago, and it should be a pretty quick answer, so I'm going to go ahead and try to sneak it in here. We're getting down to just the last couple of minutes of our presentation today, but here's a question. Is it possible to encrypt just part of the data, such as only some columns?
At least for our solution, the transparent data encryption that's included in DataStax Enterprise, the lowest level is the column family and or the table level. We do not encrypt at the column layer today.
Right, and with Gazzang, the smallest increment that we can protect is at the file level. So if you're using a system where you can kind of break up the tables into individual files, we can protect it at that level.
Okay, and that does point to another question that we had. So if it's a quick answer, go ahead and do it. If not, then we'll just get back to people privately. So this was a related question. What is the main difference between DataStax and Gazzang's transparent data encryption? Is that the main difference?
Gazzang's encryption is far more sophisticated and gives you more options, will get you past the typical security regulations of key separation management and things like that. Again, as I explained when we were talking about just DataStax Enterprise Security, ours is a very simple rudimentary form of transparent data encryption where the key is on the server, and oftentimes that is not what is required.
Sam? Anything to add to that one?
No, I agree with what Ron was saying. I think the key management is a large difference. And the other thing is, if you've got a terabyte of data and you want to protect it all, I don't know, but it may simply be easier to do it at the disk than specify all the various column configurations and things like that.
Okay. Well, thank you so much, everyone. Greg, Sam, and Robin, it was great to talk to you.